Good morning, everyone, and welcome to Chemical Engineering at UCT. My name is Peter, and I'll be taking you through this presentation. And then with me, I've got Dr. Marike Fagan-Endres, who is my colleague in the department, and Rahma Jakoud, who works in our faculty office. And they will be answering your queries in the Q&A that you've got on your facility. So what we'll do is we'll start off with a bit of a welcome to the department, what chemical engineering is, what the department is like, and of course, a perspective from our most valuable asset, our students, and then we'll go into some questions and answers. So to jump straight in, I'm going to start off with what chemical engineering is and how we do that at UCT. And to answer that first question is actually quite simple. It can be done in one line. Chemical engineering is all about changing raw materials into useful products. And so this is something that can go all the way from what people call more traditional industries, just like oil and gas and turning that into fuel, or coal and turning that into energy, but also mining metals to make cell phones, laptops, copper cables, things like that. But it ranges all the way across the spectrum to also make pharmaceuticals, for example, to extract natural compounds to make cosmetics. If you are more into the biotechnology space, where it's living organisms that help us to turn these raw materials into products, and then I'm thinking about, if you think about making yogurt, making cheese, making beer, but also meat substitutes in a lot of the vegetarian products. That's all done through biotechnology processes. And the way we do these changes is because we understand the chemical, biochemical, and physical nature of these materials. And so because of that, we then know how we can change them. And the changes happen through what we call unit operations, and that's something I will talk to just now. But of course, we don't live on an island, so we need to make sure that all the changes we make, all these steps along the way to make that product needs to happen safe, sustainable, and cost effective. And like I said, I want to come back briefly on these unit operations because they're really at the core of what chemical engineering is and what we do. And what they actually are is nothing more than generic process stages. So there's some pictures here to show you. So the first one is pills rolling off a conveyor belt. So this is where we handle solids. These are big ponds in water purification. So we need to be able to move around large quantities of liquids. Here it's water, but it can be liquid chemicals as well. We need to be able to mix complex stuff. Chocolate is fun to mix, but it's also a very sticky substance. So how do you get that all mixed properly? Then we've got the reactors to do chemical reactions from one thing to another thing. But it also involves drying stuff, filtering, separating, extruding it into shapes. And so we call these unit operations our toolbox or our building blocks, and we use these blocks to make big processes or design big processes. And as I said earlier, this can go across a very wide array of applications. And I'll just show you a few. So for example, if you think about water purification, we've got raw water sitting in our dams. We need to get some of the solid stuff in there out. And so we add coagulants in here, then we need to mix that properly and make sure that it, whatever dirt we have settles to the bottom. And then we need to separate the solids from the proper water. So we first let the heavy solids sink out a bit, but then we filter it. Then we obviously want water that has proper minerals in it, but that's also safe to drink, so we disinfect it. And then we make sure it's at the right pH for us to drink it, and then eventually it goes in our taps. And so this is one example. You'll find others with water purification that also involves using biotech. But you can see we use mixing, we use separating, we use filtering, and we use adding of both liquids and solids in here. Similar story for if you think about washing powder. So things we use, all of us use every day almost in our households. So you get the solid powder, some of the soap that needs to be added. You want that to be mixed well, so that if you put it in your washing machine, it doesn't separate out. So we dry that properly. Here you want to sometimes add other stuff like a sort of nice smelling perfume, or some make it look very pretty with the blue and the red colors in there. And then eventually, you want this powder to be all mixed properly. Then you don't want it to be lumpy, so we want it to be loose powder. So we send it through a screener, and then eventually it goes into the box that you find, or the bag nowadays that you find in the supermarket. So again, we mix, we dry, we add solids, we add liquids. So you can see those generic stages come through. The last example is marshmallows. You add the syrup and the sugar, which you then need to make sure that it properly mixes. Then there's egg whites that make it go nice and fluffy. Gelatin that gives it that nice gooey sense of it. Needs to be mixed nicely, and then so that it's nice and puffy. And then that foam needs to, you either make that into sort of long ropes, or you just push it out as the little shapes. If it's in these ropes, then you need to cut it into what you find in the supermarket. So again, there's heating, there's mixing, there's extruding, again, a whole set of genetic process stages. And because these, and I can give you many more examples, but because all of these, solid handling, liquid pumping, and so on, you need that to produce food and drinks, to make water, to make pharmaceuticals, to make cosmetics, to make energy, to make bulk chemicals, materials. In all of these industries, you've got unit operations that turn something from a raw product into a final product. And because of that, chemical engineers are involved in all of these. And so that makes that chemical engineers are extremely versatile in where they can work and with what they can go and work. And so that is actually just one part of what a chemical engineer is that ability of turning any sort of raw material into a finished product. But like I said already, we don't do that in isolation. We are part of society. And then I don't need to convince you anymore that as a society, we reached a point where we've got a big problem around sustainability. And I'm not only talking environmentally, but also socially. So we need to change the way we do things. And so a lot of the products we use today, plastics, fuels, coal, are not sustainable. And so you might be saying then, okay, yes, but it's chemical engineers that are the big problem here, because they created a lot of these processes, and to a large extent that is also true. But it also means that we're the ones that have the ability and the responsibility to be the change. We know the processes, we know how we can change these processes, and so that's what we need to do. So a lot of the current thinking in what chemical engineers do is not only turning these raw materials into products, but also thinking very carefully about how do we do that, how can we change what we do nowadays. And that combination of these unit conversions to use, or unit operations at least, to make processes and do that in a sustainable way, we combine all of that in our curriculum. And we believe that chemical engineering at UCT is quite unique, and that has different reasons. So firstly, our staff is really internationally top. So we've got quite a few highly rated researchers on an international level. We've got very strong connections with the industry. So we've got an advisory board with representatives of the industries where our graduates go and work. And so we get direct feedback from them as to what we do is still relevant for the industry. People in industry have, they plan not just 4 or 5 years ahead, which is the length of a degree, but they think 10, 20 years ahead. So they can tell us now, okay, where the industry is thinking that they'll go to in the next 20 years. So what kind of graduates they will need. And so that helps us to be a soundboard and to allow us to make our degree and our graduates better and better all the time. We combine that with modern facilities. So on the UCT campus, we've got by far the newest buildings, which also allowed us to design them a bit more targeted at what's currently needed in the way we teach the degrees. So that involves both our lab spaces, but also our teaching spaces are really geared as towards the way we want to teach our curriculum. And then the actual program is accredited by the Engineering Council of South Africa, which links to what's called the Washington Accord, and that gives the degree recognition internationally. So you can take your UCT chemical engineering degree and go work everywhere else in the world, which is quite special. We use a lot of what we call project-based teaching. So we don't just teach a concept and let you do an exercise and then move on. We let you use those concepts into real-life problems and let you design real-life solutions for them with all the complexities that come with it. And that not only gives you a sense of what it is to be a chemical engineer already from when you're studying, but also really deepens your understanding of the theoretical concepts. And we do that through supporting you all along. So it's not only lecturing staff, but we also have a big body of what we call teaching assistants or tutors. So we have a ratio there of about 1 tutor per 15 to 20 students, which is quite high. And most of those tutors are graduates from our program who have stayed on to do masters and PhDs. So they know the degree very, very well. They know where the pitfalls are. They know where the difficulties are, and they know how they got through. So they know how they can guide you through as well when you're in the program. What really sets us apart from other programs in the country and even around the world is that we have a built-in additional support program, and I'll get to that in a minute as well. But we make sure that within our mainstream program, we work with what we call a cohort system. So we try to keep the same class from first year together all the way through to final year, so that you really build those bonds across that class, but you also pull each other up to make it through the degree. And that gives us a very high success rate. So of all the students that walk through the door in first year, 80% graduate with a degree. So that is really high. So that means that everyone who comes in has a really big chance to graduate. And why people don't make it has vary in reasons. Some feel like this is not for them. They want to go do something else. So it's not just that the other 20% is people that fail. A lot of them is people who feel somewhere along the line that this study choice is maybe not there. So this 80% is really by far the highest in the country. And then the last thing we have is that our graduates are well-rounded, and I'll get to that in a minute as well when we look at the curriculum in a bit more detail, and that's over here. And so what you see, so the yellowish blocks is mathematics and science. The green blocks is chemical engineering core, like we call it. And then the darker green is when it goes more towards advanced engineering and specialization further down the degree. But if we focus on the first 2 years, what you see is that the yellow part is still quite big. And the reason for that is that we need to build a mathematical and scientific foundation. As I said in the beginning, we use our knowledge of chemistry, biochemistry, and physics to turn the raw materials into products. So we need to know that up front. We need to embed that as a skill in you. And so that's why we put a lot of emphasis on maths and sciences. In the first 2 years, the mathematics is there because these unit operations include complex calculations. We're pumping a lot of liquids around. There's a lot of gases involved and pressure and things like that. And so that requires you, if you want to then size equipment, to know how big does the reactor need to be, how long does the pipe need to be, how strong does the pump need to be. You need to be able to do the mathematical calculations that underpin that. So that comes with it as well. You see the little star here, and that's because in the second year, it's not just chemistry that you can choose. The chemical foundation comes in first year, but then in second year, we allowed students to choose between either the follow-up chemistry course, but also a biotechnology course or mineralogy. So because we know that chemical engineering is not just turning oil and gas and other chemicals into plastics and so on. It's such a wide variety of industries, and so these science options allow you a bit to explore different things there. And then if we look at the more specific chemical engineering content, so we start off with some introduction in first year, where we really put some basic concepts down, and then the contribution of chemical engineering to what you do every day as a student becomes bigger and bigger and bigger until it sort of dominates quite a lot in third and fourth year. And so what we do is in second and third year, the focus is a lot on getting these unit operations in, so that you can really understand what the underpinning theory is for those unit operations. And then from the second half of third year into fourth year, you now really start using these unit operations, as I said, as a toolbox and as building blocks to put them together in a design. So we prepare you for that in these big courses in final year. And then there's a big final year design where you, with a team of other students, need to design a complete chemical process from absolute scratch. And you do that by using your knowledge that you've built up across the years. And so one important thing to notice here, those big blocks are very big courses. And so the reason we work with these very big integrated courses is that it allows us to really monitor our students throughout the whole year. So it's not that you do a small course here and a small course there and it becomes difficult to track. We keep you together in the same group in a very big course so that we can really follow you closely, and that we can also do that additional support. So both in the winter break and the summer break, we have what we call boot camps. And so students who struggled a bit in the first semester get a chance to work on that in between the first and the second semester, so that you're all good to go again for the second semester. Same for the end of the year. If we see that you struggled a bit, the boot camps help you there to get your knowledge up to scratch. And the reason we do that is because we know that the academic year at UCT is very short. And so it's a lot of information you need to digest in a very short period. And so not everybody is able to do that. And so that doesn't make you more clever or less clever than someone else. And we all learn in a different way, in a different pace. And so having these sort of vacation programs or boot camps to allow students to catch up is really essential there. And ever since we've introduced them, we've seen that our pass rates have gone from sort of 50 to 60% to well into the 70% for each of these courses. So that really makes our curriculum very unique. But there's more than just that. If we drill a bit deeper, like I said, we do a lot of project work, and that project is usually in teams. Within those project and that teamwork and also the practicals, you need to communicate about your work. So there's this joke that's going around that chemical engineers and engineers in general are very good at doing very complex calculations, but they can't explain it to anyone what they've not actually done. I can tell you wholeheartedly, and you'll see that from the student presentation as well, that is absolutely not true anymore. Our engineers nowadays are very good communicators. And it's also essential because we need to explain to a lot of different people in different industries what we do, and that what we do is good. And so we also have health and safety that we teach in each of these years. And so that strand runs through, and we make you within that project space think about what is the economical impact, what's the environmental impact, what's the social impact, and that brings you to that sustainability thinking. And then there's computing as well. So all of these, we call that strands, and they run across the 4 years. And so within those 4 years, we build up your knowledge in that. And if you analyze what kind of skills you learn in that, so then we're talking about complex problem solving, creativity. You need to make judgments within a project. You can't do everything you want. The teamwork teaches you how to deal with other people. That's not always that straightforward, but also to show empathy towards each other, to encourage each other. The issues around social and environmental impact is around critical thinking and around sustainability, as I said. And if you then look at the skills that Forbes magazine has listed for the fourth industrial revolution, so the skills you need when you go into industry right now, then you see those same skills coming back. So it is around complex problem solving and critical thinking and so on. You see all of them here. So all of these, if you do chemical engineering at UCT, we consider that chemical engineering skill. So we make sure that during your degree, we teach them to you, you get to develop them. And this makes that our graduates don't only end up in the industries I showed before, so not only the chemical industry and the food and beverage industry, fast-moving consumer goods, but also in every other sector of that you can think of. So we have a lot of our graduates that go into banking and finance because they can deal with very, very complex data sets. They can analyze them and they can see a pattern in them. A lot of our graduates go into consultancy because they can very quickly acquire new knowledge and use that creatively to go and come up with new solutions. So the unit operations allow you to go into a wide range of industries. This extra layer of skills set you apart from other graduates around the country and also allow you to go into a much wider array even of jobs going forward. And then the last bit of this presentation is, of course, the one that everybody always wonders about is what do I then actually need to get into this program? So in your matric exam, we want you to have 80% and above for maths, 70% or above for physics. And then we add so that's the absolute minimum requirement. And then we take your English, maths, and physical science score with the score of your best 3 subjects. And then you need to get, so that's 6 in total. And so we call that a faculty point score. And so if that score is higher than 510, you automatically get into the program. If you get a weighted score, so this is a score that's weighted with a certain factor that takes into account the kind of school you went to, your first language, the sort of how many people in your family that have gone to university already. So a lot of more sort of social factors around your background that sort of give us a sense of how difficult it was for you to get to this point. We wait that's in that weighting, and that corrects the score of these 6 subjects. So if you've got 80% on average for all your subjects, you very likely get in. And I've put that between brackets because the last couple of years, everybody that falls into this category has made it in. And then we've got a C category, and that depends on where you see that the score is allowed to be a bit lower. And that depends on how many applicants we have for the program, and how the metric scores are in general, and if we need to adjust across our groups that we want to admit to the program. So it is very steep entry requirements, but that's also because it is a difficult program. But then we also feel that once you get in, we have the responsibility to make sure that we do everything that we can to make you successful, and that's why we have that high 80% graduation rate in our program. So that was it from me in terms of what chemical engineering is and how we do it at UCT. The next thing I'll show you is a little video about our custom facilities on the campus. And we'll have a look at what our students have to say. So these are our class reps from the class that's just graduated, and they'll give you an insight into how their experience was of their degree.
We asked some of our recent graduates to tell us about their UCT chemical engineering experience. Let's meet them and hear what they have to say.
Hi, my name is Taneo Galela and I'm born and bred in Bloemfontein.
It's Tiana Hansraj and I am sitting in Johannesburg at the moment.
Hi, my name is Abdullah. I'm originally from Durban, but I spent most of my life growing up in Saudi Arabia.
Hi, I'm Catherine from Cape Town.
Tell us about why you chose UCT Chemical Engineering.
I chose UCT Chem-Eng because I was lucky enough to be awarded a full bursary when I was in matric, and at the time I heard that UCT was the best university in the country, still is, and as a result I decided to pack my bags and fly on over to sunny Cape Town, and I haven't regretted it since.
So I chose chemical engineering because of the endless doors it opens in terms of your career after your study, and you also get to learn a unique set of problem-solving skills that will equip you for your future.
I chose UCT Chem-Eng because I love solving problems and working in teams. UCT because of the mountains and the beach, obviously.
I went to school just down the road from UCT, so it was a natural progression for me to go to UCT. And in high school, I loved maths and chemistry, and I'd heard that chemical engineering would open many doors.
What did you enjoy the most about the UCT Chemical Engineering degree?
What I enjoyed most about the degree was hands down the collaboration between myself and my classmates. I don't think I would have gotten through this journey without their help, and I'm so grateful for the relationships that we built and just for the way we approach problem solving, especially during a pandemic in final year.
So what I enjoyed most about my degree was meeting an amazing group of people who I worked very closely with for my time at university. The other thing I really enjoyed was how well equipped I felt leaving my degree and moving into the working environment. Chemical engineering is a very unique degree and it opens so many doors for you, and that's what I really enjoyed.
What I enjoyed the most about the degree was the complexity and the range of topics that we got to learn about. I also really enjoyed all the friends that I made along the journey and the department, which was incredibly supportive.
Because of ChemEng UCT, I've met some of the most amazing people and formed the most incredible friendships, and I'll be forever grateful.
What was the most difficult part of the degree?
I think the most difficult part of doing this degree was getting through each day and not knowing which disruption is going to come at you, but constantly having to just push forward no matter what. I think the COVID pandemic was probably the most challenging because doing final year in a pandemic is really difficult if you don't have your classmates nearby. I think we relied a lot on each other, and connecting from miles away was quite a challenge, but we managed to do it and I'm really grateful.
Chemical engineering is a difficult degree. It's got quite a heavy workload compared to other degrees, but being able to overcome that and managing that is an invaluable skill. And something that I loved was we got a lot of support from lecturers, your tutors, etc. But biggest form of support were my other classmates going through the exact same thing.
The most difficult part of the degree was working under intense time constraints to solve difficult projects, all of this in a team.
The most difficult part about ChemEng UCT is definitely all the group projects where you get very little sleep for at least a week.
How did UCT Chemical Engineering help you grow as a person?
I think going through ChemEng at UCT made me a really resilient person. I don't really think that there's a lot of things that can get me down. Didn't always have the easiest upbringing and stuff, but I think going into ChemEng it pushed me even further. It made me even stronger, and it definitely helped me grow into a strong young woman who is ready to take on the world.
Besides the content that I was able to take away, it's that invaluable set of soft skills that I really value. It's being able to work in teams effectively, being able to collaborate with different people from different backgrounds. The problem-solving methodologies that you figure out along the way are applicable across all industries and all disciplines, and those are some of the things that I really, really value about my degree.
UCT ChemEng has helped me become incredibly resilient as an individual and has also allowed me to work really effectively in teams.
You are constantly working in groups and with other people during group projects. So UCT ChemEng really provides you with the tools to be a team member and work with other people. It also helps you negotiate your time and your time management skills so that you can do other activities outside of ChemEng.
Any last bits of advice for our aspiring applicants?
As difficult as chemical engineering may be, I believe in pushing yourself beyond your boundaries, and I believe in applying oneself. So don't let what other people say about ChemEng deter you. If you feel it in your gut that you can do this and that you have what it takes, then you have what it takes. Just learn to lean on others and give it your best from the very beginning. Good luck. Bye.
I highly encourage you to join the UCT ChemEng department. It is a roller coaster of a ride, but it's something you will never regret. And for your career options and wanting to keep your career options open, it's one of the best degrees to do so.
Come join UCT ChemEng and change your life. Bye.
We have just celebrated our 100th graduating class of chemical engineering at UCT. So come be a part of the next 100.
So that's unfortunately where we need to end it. Our time is up. You have the option to post questions in the Q&A, so please do that. We will try to answer as most of them as we can. But more important, and we'll also put some contact details there for you. But most importantly, find us on Facebook and Instagram, and post your questions. If you have more questions, ask them there as well. So we have, it's at UCT Chemeng. We've got people monitoring those feeds all the time. So please go to the socials and follow us there, and ask your questions there. We can help you there as well. And then I want to thank you for your time, your attention, and your interest in Chemeng. And I hope we've given you a good idea of what Chemeng is about at UCT. And we will also post these videos on our website fairly soon. So if you want to look back at them, you'll find them there as well. So a good day to all of you from my side.